Hello everyone, my name is Shania Rai and I'm really grateful for the opportunity to present my project today. First of all, I would like to sincerely thank Emotex for giving me this opportunity to be part of this internship program. It has been a very valuable learning experience for me. During this internship, I got hands-on exposure to important technologies like IoT systems, Arduino-based development, Pixel Lab simulation, and ThingsBoard cloud platform. This experience not only helped me understand the theoretical concepts, but also gave me a practical knowledge of how real-world IoT systems are designed and implemented. Through this journey, I learned how different components like sensors, microcontrollers, communication protocols, and cloud dashboards, they work together to build a complete smart system. So today, I will be presenting my project titled Smart Factory IoT Monitoring System. Now this project focuses on designing a smart industrial monitoring system that can collect real-time data, automate responses, and allow remote control of devices using IoT technologies. Okay, before going into the solution, let me first explain the problem this project is trying to solve. So before designing any system, it is important to understand the project. In traditional industrial environment, monitoring is mostly done manually, and this leads to several challenges. First, there is no real-time visibility. That means conditions like temperature or machine status, they are not continuously tracked. Second, there is a delay in responding to issues, which may further result in equipment damage or production loss. Third, industries rely on reactive maintenance. Now, where problems are fixed only after failure occurs. And lastly, there is no remote accessibility. So engineers must be physically present to monitor or control the systems. Now, these limitations, it reduces efficiency, it increases downtime, and also it affects overall productivity. Okay, so to overcome these challenges, the proposed solution is a smart factory IoT monitoring system. Now the system uses IoT technologies, monitor industrial conditions in real time, and it not only collects data, but it also automates responses, it also generates alerts, and it also allows remote control through a cloud dashboard. Now this system is designed to be efficient, scalable, and suitable for real-world industrial applications. So going to the main objectives of this project, and they are first of all it's to implement real-time monitoring of industrial parameters. Second, to automate critical operations like ventilation. Thirdly, to enable remote control using cloud-based system. And lastly, to design an intelligent alert mechanism. Now these objectives ensure improved efficiency, safety, and decision making in industrial environment. Now let me give a quick overview of how the system actually works. Now this project is designed as a 2-node IoT system. Now the first node is deployed in the production line, where it monitors machine related parameters, and the second node is deployed in the warehouse, where it monitors environmental and security conditions. Now both nodes, they collect the data using sensors and send it to the cloud using MQTT Protocol. Now the data is then visualized on the ThingsBoard dashboard, where users can monitor and they can control the system remotely. Now moving to the system architecture. So the system follows a 3-layer architecture. First is the perception layer, which includes the sensor and Arduino devices that collects data. Second is the transport layer, where MQTT Protocol is used to send data to the cloud. Third is the application layer, which is a ThingsBoard platform that displays data and allows control. So overall, the data it flows from the sensor to the Arduino, and then to the cloud, and then finally to the user dashboard. Now let's move to the node 1, that is the production line. Actually, it is used for the production line. Now this node monitors machine and environmental condition using multiple sensors. It includes DHT22 sensor for temperature and humidity. It uses LM35 for precise temperature measurement, and it also uses a vibration sensor to detect machine behavior. It also includes relay control and LED indicators. Now this node helps in identifying abnormal machine conditions early and allows us to improve the maintenance efficiently. Now moving to the node 2, which is used in our warehouse for environmental monitoring and security purpose. It includes again DHT22 for temperature and humidity, PIR sensor for motion detection, LDR for detecting light intensity, and door sensor for monitoring access. It also controls a ventilation system automatically when required. This ensures both safety and proper storage condition. Key features of our overall device: we have the system provides several important features like real-time monitoring with frequent updates, multi-node data integration, remote control using cloud dashboard, automated decision making, sensor fault handling, and alarm generation. These features make the system reliable, efficient, and suitable for smart industrial environment. Now, one of the key highlights of the system is automation. Now, for example, in the warehouse node, if the humidity level it becomes greater than or equal to 85%, the system automatically turns on the ventilation system, and this happens without any human intervention. Now, at the same time, the system logs the event and updates the dashboard. However, user can still manually override the system using commands, giving both automation and flexibility. Now moving to how the system communicates with the dashboard. Okay, so the system, it uses MQTT Protocol for the communication purpose. It follows a publish subscribe model, which actually where devices it sends data to a broker and the cloud platform receives it. Now this makes communication lightweight, fast, and reliable, and which is hence ideal for IoT applications. Now let's move to the dashboard. Now what it is, the ThingsBoard dashboard, it provides a complete visualization of the system. It includes live gauges for temperature and humidity. It also includes charts to track the trends. Many status indicators we have alarm notifications, and also control switches for remote operation. This allows users to monitor and control the system from anywhere around. no need for manual intervention. People living far away still can manage that warehouse or the production line through the remote switches we have, the control switches we have. Now talking about the alarm system, how it works and all. So the system also includes an intelligent alarm system. Basically, for example, if our temperature it exceeds 35 degrees Celsius, a critical alarm may generate, or critical alarm is generated. And let's say if humidity exceeds 85%, so the ventilation is activated and an alarm is triggered. Same goes for the sense of failure. If a sense of failure has happened, it can be also handled and reported. Now this ensures safety. It also ensures quick responses to abnormal conditions. Now that I have explained the system design and working, let me just demonstrate how the system performs in real time. So yes, let's move to the demo part. Now I will be demonstrating the working of my smart factory IoT monitoring system. So first of all, I would like to say that here we are using Pixum Lab to simulate the hardware nodes and using ThingsBoard as a cloud platform for monitoring and control. So as you can see on the screen, I have two nodes. Node 1, which represents the production line, and the node 2, which represents the warehouse environment. Now, let's look over here. So on this ThingsBoard dashboard platform, we can observe real-time sensors data, right? Such as, just look at it, the temperature, or we have humidity, or we have motion detection, machine status, and just look how the data is continuously updated at regular interval using the MQTT protocol. Now let me change some values, sensor values in the simulation, and then we will have a look over here. So now as you can see, I'm changing the value in the Pixum Lab spare parts. You can see how the values on the dashboard, it's updated instantly, which shows the real-time communication is working correctly. Now first let me show you the whole node 1 demo first. So just look at the node 1, which represents the production line, right? And here we are using like DHT22 for temperature and humidity, LM35 for machine temperature, and a vibration for machine condition, right? So just look, as I am increasing the temperature, you can see that the dashboard, it reflects the updated value immediately, and this helps operate, monitor machine health continuously and take action before failure occurs. Same if I am changing the humidity, it's also reflecting over here. Also the LM35, the way I'm changing the values, it's being reflected into the dashboard platform we have. Okay, so now quickly let's see the node 2 demo we have. Okay, so moving to node 2, here what we have a motion detection. For that we are using a PIR sensor. Next we are using an LDR for the light detection purpose. Also we have a switch for the door open or door close purpose, and again the temperature and humidity, like DHT22 sensor for tracking the temperature and humidity we have. And same, I'll simulate the motion detection first. Let's see. So as I'm triggering the PIR, you can see the dashboard immediately shows that a motion detection, a motion has been detected over there. Yeah, which can be used for security monitoring. Okay, so let me trigger some more values and just look how, as I am changing the values over here in this Pixel Lab simulation, the values are being reflected on the dashboard platform, right? So yeah, as you can see, the dashboard immediately shows motion detection or any other detection. It's the change in the temperature or the humidities, anything. It is used, and we can use it for the security purpose or for monitoring it. Now I will demonstrate the automation feature we have, which is a very key highlight of this project. So currently the humidity level is below the threshold, as you can see. Now what I will do is I will increase the humidity value beyond 85%. Let's see what happens. So as soon as the humidity it crosses the threshold now, you can observe that the ventilation relay it automatically turns on, right? And this shows that the system can take decision automatically without human intervention, right? And at the same time, the event is logged and displayed on the dashboard. Now let's move to other parts we have. I will demonstrate remote control using RPC. What it is actually, even though the system is automated now, user can manually control devices from the dashboard itself. For example, I can turn off the relay manually, right? Just look how I'm turning it off. As you can see, the command is sent from the dashboard to the device, right? And the relay state changes instantly. So this shows a two-way communication between the device and the cloud. Now quickly look at the alarm demo we have. So if any critical condition occurs, the system generates alarms. Now for example, if a temperature it exceeds a certain threshold, a warning or a critical alert is being generated on the dashboard, and it helps in quick decision making and improves safety. So through this demonstration, what we all observe, we can see that the system successfully demonstrated monitors the data in real time. It also performs automated actions. It supports remote control and it generates alerts. Now this makes the system efficient, reliable, right? Now moving to, as we have observed in the demonstration. So as we observe in the demonstration, the system successfully performs real-time monitoring, automation and remote control. Now I will briefly discuss the result and overall performance of the system. Now in conclusion, our project demonstrates how industrial operations can be transformed using a very simple yet powerful IoT monitoring system. Through this implementation, we can show that smart factory concepts are not limited to large-scale industries. Rather, they can be achieved using affordable and accessible technology. One of the key achievements of our system was the real-time visibility into the factory operation. It allows operators to monitor condition instantly and make faster, more informed decisions. Along with that, we have implemented automated responses, which significantly reduces the need for constant human intervention, improving efficiency and minimizing errors. Another important advantage is remote accessibility. Now this means the system can be monitored and controlled from anywhere, enhancing flexibility, convenience. Additionally, our design supports scalability, allowing more sensors and nodes to be added easily as the system grows. And Looking ahead, this project has strong potential for future enhancement. It can be expanded with mobile application too for easier user interaction. It can further integrate it with AI-based predictive maintenance to prevent failures and before they occur, yes, and connected with enterprise system for complicated industrial automation. Now, overall, this project is a step towards smarter, safer, and more efficient industrial environments. Thank you. Here I'm gonna end it.